Welcome to the Maths for Graduates. Today we'll see the proof of Morera's theorem. So let's start. A statement of the theorem is if f is continuous in a domain S and integration of function f of z in contour gamma is 0 for every closed contour gamma in S, then f is analytic. Okay, and I have something to remind you. If you remember, in one of my previous lecture we have seen Cauchy's theorem. Cauchy's theorem states that if f of z is analytic, then integration of function f of z in contour gamma is 0. This is Cauchy's theorem. So you can see Morera's theorem is somehow converse of Cauchy's theorem. Now let's get back to the main point of discussion. So before we begin the proof of Morera's theorem, let's discuss a problem related to this theorem. So integration of function 1 over z square dz in circle mod z equals to 2 is 0. You know that integration of this function will be 0, but function f of z 1 over z square is not analytic mod z equals to 2. Now the question arises, is this function a exception to Morera's theorem? No. Why so? Because this function does not meet all the conditions of Morera's theorem. This function 1 over z square is not continuous at z equals to, which is inside the circle mod z equals to 2. Hence, the condition of continuity cannot be relaxed. Okay, I hope everything is clear to you till now. Now let's come to the proof of this theorem. So to prove, will be needed a lemma. Let me write it down here. If f be a continuous function in a domain S, then the following statements are equivalent. Statement 1, f has an antiderivative in S. Statement 2, for any closed contour gamma in S, integration of function f of z dz equals to 0. Statement 3, the contour integrals of function f are independent of paths in S. Now let's begin the proof. It is given that integration of function f of z in contour gamma is 0. So from L1 f has an antiderivative in S. So f has an antiderivative in S, that is capital F prime z equals to small f z. Okay, which means derivative of capital F z exists, which implies function capital F of z is analytic. And we know that if any function is analytic, then its derivative is also analytic. Hence, capital F prime z is also analytic, and this f prime z is nothing but small fz. So which this implies small f of z function is analytic. Okay, and this completes the proof of this theorem. Okay. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSRNet, GATE and other MSc entrance examination can buy our complex analysis handwritten notes for a very reasonable price for only ₹50. This notes contains lots of problems and concepts. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.